Okay, is it Wingardium Leviosa or Wingardium Leviosa?
I'm pretty sure it's Wingardium Leviosa, not Leviosa.
Oh, gotcha.
Yeah.
Whoa. Didn't see you there.
Hey, welcome to today with us. I don't know.
Just we're here for another great segment of the magic of cooking. Woo! All right, today we're gonna make kuka, which is a Dutch spice cake. All we're gonna have to use is some sugar that I have right here, some flour, some brown sugar, very different, 4 eggs, some Crisco for our fat, and we got some spices here. First we have our cinnamon, then we have our cloves, and our allspice, and our nutmeg, and our baking soda, with a little pinch of salt right there. So what I'm gonna have Karen do is I'm gonna have her do the cooking for me while I teach y'all about the chemistry. So what's really special about this is I said it's a spice cake. So we have 4 spices. We have allspice, cloves, cinnamon, and nutmeg. And each of these has characteristic molecules that determine its aromatic smell and its taste. Want to just proceed, Karen?
Yes.
With that first. All right. So for allspice, we have what we call eucalyptol, eugenol, and caryophyllene, which, would you imagine, I have a cute little board full of these compounds. So I'm just going to bring these up here. Here you will see our eugenol, which is a phenolic, which means it is more water soluble than something like a terpene that we have right here. So what's special about terpenes is they're made of simple 5-carbon monomers, and then they can polymerize, or they can combine together to make a variety of compounds, as we will see when we look at these compounds. So we have our eugenol, which, as I mentioned, right here is part of allspice, and it gives a lot of the smell to cloves, which we also have. We have our caryophyllene, which is a sequiterpene, so it means it's also a terpene, and we have our eucalyptol, which is a terpene. So if this is more water soluble, then this is less water soluble, so it's going to be highly soluble in our fat, which is our shortening, and fats actually mellow out the flavor, and they make the big parts of our compounds, they make the flavor more persistent and gradual. So we have Karen here, she's adding some eggs. That's going to add some emulsifiers with our lecithin, and we added our flour too, and that's going to add the body of our cake. And then we will be adding all of our spices, which will add the flavor to our cake. And I'm just going to get back to our cute little compounds here. So once again, for cloves, we do have eugenol, which is the big one for cloves, and then we have eugenyl acetate, which is right here, followed by, once again, caryophyllene, which is right here, once again a terpene. For cinnamon, we have a whole slew of things going on here. We have eucalyptol, linalool, which is this one, somewhere. Linalool, caryophyllene, cinnamon acetate, cinnamyl acetate. That's cinnamon, isn't it? Yeah. Eugenol again, and then cinnaldehyde, which is our big one for cinnamon. Kind of makes sense, right? Because it's cinnaldehyde, has cinnamon in it. And then lastly, we have nutmeg, which has saponine, eucalyptol, pinene, which is a terpene. You'll notice that a lot of these are terpenes, so they have a similar chemical structure, very hydrophobic, so they'll dissolve in our oils. Limonene, which is here, geraniol, safrole, myristicin, which is here, myrcin, and then methyl eugenol, which is here. And you'll notice there's just a change from this OH to a methoxy group. Like I said, these are all just going to add a lot of flavor and body to our kuka. And I will just help Karen now with our splash of coffee. And it'll just We're just adding a little bit more moisture. This is decaf so that it's friendly for everyone to be drinking and eaten, consuming. And we're just preheating the oven to 350. We're gonna bake this for 20 minutes. And that's what's going on there. So as you can see, we have a nice little brown mixture here. I'd just like to mention that cloves and allspice are part of the same family, the myrtle family. And allspice has actually been described as having the flavors of cloves, cinnamon, and nutmeg. Imagine that, the three things we're also adding. So we're just enhancing the flavors here. And just to note, cloves, they go through a browning reaction similar to what we learned for our meats and breads. We're going to see the plant has come from the seed. We're going to see the sugars and the proteins combined together to make all our browning reactions products that are going to add a lot of, once again, a lot of body to the cloves and then also to our spice cake. So Karen's just going to slap this down right here, and we're just going to smooth it out, get it to all the edges. The consumption of raw things that have egg in them, they may cause salmonella. This was a choice of Karen only. We're just going to put this in the oven now. 20 minutes. Checking on her a little later. Timer, where are you? There it is. Start.
About
There
60
goes our
seconds.
timer. We're going to pour poop it out.
Yum.
You can see it's significantly browned. For people here, they'll note it smells a lot like cloves and allspice. That was really hot on my hands. Just gotta put this up here for the marker. This is teapot. So it darkened, so that means that we went through some browning reactions. I forgot to mention while we were making this, during the 19th century, the Dutch controlled the trade on nutmeg. So that's one of the leading reasons why we have nutmeg in this recipe. Karen's poking at it, seeing how good we cooked it. And a lot of our information came from McGee. Pages 391 to 423. Very good book. You should. It's a good read. You should buy it if you don't have it. You'll be entertained. Days and days. Now, I think we're going to take a little break. Going to get ready for our next segment. See you then.
Okay, so welcome back to our cooking segment. For the rest of the show, I'm going to be cooking fried rice. And I'm kind of doing it the cheating way with the rice cooker, but that's okay. So here's the white rice that I'm using. And first you kind of want to rinse it off, so you'll swirl, then dump out the water a few times until it's pretty clear. And usually the rice, or the water to rice ratio is 2 to 1. So I added 2 cups of rice, so I'll add 4 cups of water. Oh no, I didn't use this. Okay, so a trick also is if you kind of measure incorrectly, if you put the tip of your finger on top of the rice and then all you have to do is add water up to the first line of your finger. That's just a good trick in case, I don't know, you lose count, which I did because I did not use this cup earlier. I used the rice cooking cup. So yeah, you just lay your fingertip on the surface of the rice and then that's how much water you need at your first knuckle line. So we'll start that. And then now I'll talk about the rice we use, kind of the chemistry behind it. So rice is just a grain and this is the seed, but for white rice we mill away the other part, so we're just left with the endosperm. And the endosperm is composed of proteins and starches. So our 2 starch molecules are amylose and amylopectin. Not sure if I said this correctly, but the amylose is just like a long chain, and then the amylopectin is a lot of different branching points on it. And where's the marker? So the rice, starches on the rice without water, just like this raw form of it, they're packed very tightly on the surface or just throughout the whole thing. But as we're cooking with the rice cooker, with heat and water, it kind of breaks these intermolecular forces and it leaves more hydrogen bonding so the water can fill it up and it's more spread apart. So that expands and lets the grain to swell. So that is called gelation, starch gelation. And then fried rice actually takes about 2 days to do it or a night, because after the rice cooks, we don't want to have mushy or soggy fried rice because it's going to be warm and moist. So I'll actually, when it's done cooking, I'll put it in the refrigerator so that it can dry up. And how it dries up is as the rice cools down, these starch molecules, they actually come and bond together, but like not as perfectly as before. And it re-hardens the rice, dries it out as water is pushed out when those bonds reform, and this is called retrogradation. And that is the secret to very good fried rice and gives it its yummy texture. So I will get back to you tomorrow when that is ready. Okay, so welcome back to day 2 of cooking with the fried rice. It sat in the fridge overnight, so it's nice and dry, did the retrogradation. So for fried rice, you can add pretty much anything you want. Today I'm going to make it really simple. I'm just adding eggs and then green onion and bacon bits. But you can add like frozen vegetables or cabbage or anything you want. But I'm going to talk about the chemistry of heating up eggs and how it solidifies. So right now we just have raw egg and it's mainly water and proteins, but if you see from this diagram, the proteins are compacted into little structures and they're just bonded to each other, but they each have like a negative charge on it, so they kind of repel each other, so the water can freely flow through it. But as I mix the eggs up, and even if you heat it, the eggs, then the protein structure becomes more linear because we're breaking those bonds holding it in place. And the protein structure in eggs is really what makes it solid and adds color to it. So I'm going to, should turn it on. Another thing about eggs is when you cook it, or scramble it especially, you want to do it on low heat, low medium heat for a long period of time. Because if you do it too quickly or too high of heat, then these proteins, when they rebond together, like as you heat it, they'll make this kind of meshwork. Then too much of that is going to make the egg really rubbery, and you don't want that kind of consistency. But also, as this meshwork is formed, it reflects light, so that's how the egg will get its color rather than being translucent. Okay, so now we're just going to scramble the eggs. Now we add everything else. Yum! Thanks for joining us.
It's been a roaring good time.
I like our food. It's delicious.
That's it.
Yeah, that's all.